Viewer discretion is advised. Note I've always wondered, what's the maximum distance you can fire a Nerf gun and hit someone?
I hate Justin Bieber.
Let's shoot him.
I wonder how a Nerf gun works.
Let's find out.
Shooting a Nerf gun is a simple example of a projectile problem. Projectile problems involve an object traveling through the air. Our objective in this experiment is to find the maximum displacement in the x direction, or the range, that a Nerf dart will travel if shot at a 45-degree angle. Shooting the gun at a 45-degree angle will yield the farthest range because the x and y components, in this case the velocities of the dart, will be the same. This free body diagram shows the forces acting on the Nerf dart after it is shot through the air, which is only the force of gravity acting down.
This is a basic Nerf shotgun. To load it, we'll need to pull back this barrel into an L form, and we'll insert the shell with the bullet into here. Now, the shell and the bullet both have openings at the bottom, and that creates a place for air to go through, shooting the dart through the barrel onto our target. The ropes pull the chamber, and the air inside it becomes compressed. Now, whenever you cock it back to its original position and pull the trigger, the air is released, allowing the bullet to fire through here and out to your target.
Okay, this is how we got our displacement in the x direction. We took the time, or the velocity, the initial velocity, and we used that to find the initial velocity for the components in the x and y direction, which ended up being 7.69 meters a second. We then plugged that in for velocity initial in the y. We took the displacement of -1 meter and the acceleration of gravity as -9.8 meters a second in the y direction. We then used this kinematic equation right here, and we plugged in velocity initial in the y and acceleration in the y and the displacement in the y direction. And then when you solve that for 0, you are able to plug it into a graph and get your answer if you find the zeros, which our time ended up being 1.33 seconds. We then took the time to find the displacement in the x direction and multiplied it by the initial velocity, which was 7.69 meters a second. Once we plugged that in and multiplied them together, we got our final answer of 10.23 meters.
And this is our target.
Boom, baby.
Alright, we're shooting the gun from here towards the Justin Bieber target. The displacement off the ground is 1 meter in the y direction, and we're measuring a 45-degree angle from the horizontal with this protractor. Right here. Right.
That's good enough.
Yeah, it's good.
And then,
Ready?
45 is like right there.
1 meter off.
One more thing left to do.
Alright, so have you guys been wondering why I've been carrying this gun with me the whole time? Well, this is why.